Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 22nd, 2025, about 2 days ago. This paper introduces a new training method that dramatically improves how well a model knows what it doesn't know, reducing a key error metric by over 90% without hurting accuracy. The paper is titled, Beyond Binary Rewards, Training LLMs to Reason About Their Uncertainty. And the implications for creating more reliable and trustworthy AI are quite significant. Essentially, the authors tackle the problem of models becoming overconfident when trained with simple right or wrong rewards. So, to solve this overconfidence, the authors introduce a method they call reinforcement learning with calibration rewards, or RLCR. Instead of a simple right or wrong reward, this new approach also scores how well the model's stated confidence matches its actual correctness. This first figure really highlights the difference. On the left, you see a sample output where the model uses special tags to think, analyze its own uncertainty, and provide a confidence score. The charts then plot accuracy against calibration. A good calibration score means the model's confidence is reliable. The new reinforcement learning with calibration rewards method improves both moving the model up and to the right on the chart towards the ideal outcome, even on new unseen tasks. Building on that, these next charts really get to the heart of how this works. On the left, we see the old reward system called reinforcement learning with verifiable rewards, or RL versus R. The reward is flat. You get a full point for a right answer and 0 for a wrong one, no matter your confidence. This system basically encourages guessing. But on the right, the new reinforcement learning with calibration rewards method changes the game. It adds a Breyer score, which is a rule that penalizes the model for being overconfident when wrong. So now, the highest reward comes from being both correct and highly confident. And these charts show the results of that new reward system during training. On the left, you can see that both methods get better at correctness over time. The reward scores go up. But the new reinforcement learning with calibration rewards method also gets a huge boost in its Breyer reward. That's the dashed line, showing its learning to be well calibrated. Then, on the right, we see something interesting. The length of the model's reasoning, its completion length, actually grows over time with the new method, suggesting it's learning to write more detailed uncertainty analysis. Okay, this table then details the performance. It looks at accuracy and a few calibration scores, like expected calibration error, or ECE, which is the average difference between a model's confidence and its real accuracy. Looking at the top half, for the hot pot QA task, the new reinforcement learning with calibration rewards method keeps accuracy high, but dramatically improves calibration. The expected calibration error drops from a poor 0.37 to an excellent 0.03. Even more impressively, on new out-of-distribution tasks, it's the only approach that improves both accuracy and calibration. Alright, so after seeing those performance numbers, the next logical question is, how consistent is the model's confidence? These charts dig into that. On the left, a histogram shows the standard deviation, which measures how much the confidence score wobbles when the model reanalyzes the same answer. The values are tightly clustered near 0, which shows the model is very self-consistent. Then, the swarm plot on the right is even more telling. For mutually exclusive answers, the confidences should ideally sum to 1. The new method, in pink, stays much closer to that ideal line, even on new tasks. The old method, in blue, is all over the place, showing extreme overconfidence. So to wrap up our discussion of this paper, we've seen that simply rewarding a model for being right can teach it some bad habits, like guessing and being wildly overconfident. The key takeaway here is that by changing the reward system, by adding a Breyer score to penalize misplaced confidence, we can train models that are not only accurate, but also have a reliable sense of their own uncertainty. This improved calibration makes them far more trustworthy, especially when they encounter new problems. That's all for this week's AI Research Roundup. Thanks for tuning in.